Okay, we're getting ready for the test. Now, first thing, here's a freebie. We forgot to take this off the test. There's a question on the test that says motion in a straight line is called. And the answer to that is 1D kinematics. That is one-dimensional kinematics. So one dimension means left and right or coming at us or going away from us. That's a straight line. And 2 dimensions is when things go left and right but fall at the same time. Or rise, something like that. All right, then 3 dimensions would be coming back out at us. So there's a freebie. There's one question you get right, hopefully. Okay, here's our formulas that we'll be having. And so we've finished working the free fall, and now what we have to do is use all of these equations. You'll use all of them. On the test, each one of these will be used at least one time. When they ask you to solve for a ground problem, like it says, what is the speed? Okay, solve using where it says v something. Okay, so we're giving you the equation so that whatever it asks you to solve for will be found on the left-hand side of the equal sign. So if they ask for acceleration, there are two ways to solve for acceleration based on what they give you. If they ask to find distance or height, that's a distance. So delta x, delta x, delta x. There are 3 equations based on what they give you, 3 ways to solve for delta x. So you have to read the equation and figure out which equations to use by looking at the problem and figuring out what they give you. So let's see how to do our test review. Okay, so these are found on one of our worksheets. Okay, let's see how many interruptions we get today. So velocity table. Here's the time over here. It goes 1, 2, 3, 4, 5. So this is the time in seconds. So every second we take a mark of the velocity of the car as it comes down. So car Q, is their velocity changing? It's 3, 3, 3, 3, 3. That means it's moving at 3 meters per second all the time. So for this one, it has a 0 acceleration. So that's car Q. Car R, it goes from 0 to 5 meters per second, to 10 meters per second, to 15 meters per second, to 20 meters per second. So how much is it changing? Remember, acceleration equals change in velocity over time. Since this one is changing 5 for every second, that means it has an acceleration of 5 meters per second squared. So that's car R. Car S, it starts at 12, then goes 14, 16, 18, 20. So the change in velocity is 2 for every 1 second. So that means it is the answer to 7. All right, where were we? Okay, so then our last car, car T is going from 10 to 9 to 8 to 7 to 6. That means it's changing by a -1 per second, so it has a negative acceleration. So that's how you read the chart. All right, determine math problems. Lots of math problems, and again, every single formula that's at the top of the page is going to be used at least once. Okay, and if we're doing free fall, then our understood acceleration is g, which is -9.8 meters per second squared. So number 8 says, determine the acceleration of a zebra that is traveling 12 meters per second, which accelerates to 19.3 meters per second in 2.75 seconds. So what you have to do is identify each of your numbers and tell us what it is. I mean, that's not part of the test, but it's how you're going to choose which formula to use. There are 2 formulas to solve for acceleration. In both of them, you know the VI and the VF, but in one of them you use time, and the other one you use the change in distance. So we want the one that uses time. So you look through those and you say, oh, there's VF minus VI in parentheses divided by the time. That's our normal acceleration equation, and that's what you're going to do. 19.3 minus 12 divided by 2.75. And that answer is 2.65 meters per second squared. Okay, the next one is, what's the acceleration of a car traveling 85, slows to 55 in 3.78 seconds? Same thing, we have an initial velocity and a final velocity and time. So it's the same equation, but in this one we're slowing down. So we're going from 55 miles an hour and from 85 miles an hour we're slowing down to 55. So it goes in as 55 minus 85. That means we're going to have a negative for our acceleration. And that means you're slowing down. So our answer is negative 7.94 miles per hour per second. And that's how you'd see a braking distance or braking acceleration done. Okay, the next one says how far. How far is a distance, and our symbol for that is delta x. And we have three different delta x equations, so you have to figure out what they give us. So how far will a car travel if it slows from 65? So that means we're going 65 to begin with, then we slow down to something else. We have an acceleration, and we have a time period. So they never tell us what the final speed is. So what we have to do is find a formula that has delta x, our initial velocity, and acceleration and time. You look for those equations, see if you can find it. Pause the video and see if you can find it. So if you did that, you found VI times T plus 1/2 times A times T squared. So you plug that in, 65 times 3.45 plus 1/2 times negative 3.5 times 3.45 squared. So let's see here. Let's see if I can move this stuff over just a little bit. Oops, wrong one. Come on. What I'm going to do is get... All right, hold on a second. All right, I'll just write it over here. Sometimes this board isn't worth anything. 3.45 squared. I'll put it down here, 3.45 squared. So 65 times 3.45 plus 1/2 times negative 3.5 times 3.45 squared. And the answer to that is 218 meters. So it takes 218 meters to slow down during that time period. A car traveling at 25, that's a VI, accelerates at 6.7 meters per second squared, that's my acceleration, over a distance of 400 meters, distance is delta x. What's the final velocity? So we have two final velocity equations, so you got to find the one that has a VI, an A, and a delta x. And you have to label this correctly. That is VF squared equals VI squared plus 2A delta x. So 25 squared plus 2 times 6.7 times 400. Put that in your calculator. And your new speed is 77.36 meters per second. All right, number 12 and 13 are reading this graph. This is a velocity versus time graph. And remember, this gives you a relationship, velocity divided by time. So when you find slope, slope will tell you the acceleration of the problem. So number 12 says, what is the velocity of the car at 8 seconds? So at 8 seconds, we're going 40 meters per second. And the acceleration between 8 and 4, or 4 and 8, the slope is going to be 40 minus 20. So 0.1, 0.2. So 0.2, the y is 40, and the x is 8. And at 0.1, the y is 20, and the x is 4. So we have 20 divided by 4, and that answer is 5. So our answer for acceleration is 5 meters per second squared. What's the acceleration of an object with an initial velocity of 15, experiences an acceleration over 4,500 meters, meters is a distance, and it reaches a final velocity of 65. So what's the acceleration when we have a VI, a VF, and a delta x? Looking at your equation sheet, it's A equals VF squared minus VI squared divided by 2 times delta x. So you plug your numbers in. 65 squared minus 15 squared. Make sure you put that in parentheses. Divided by, and make sure you put this in parentheses, 2 times 4,500. And the answer is 0.44 meters per second squared. If you're not using parentheses, you won't get the right answer. What is your displacement? Displacement is a distance, so that's going to be delta x, so we're looking for a delta x equation. If you have an initial speed of 13, so that's VI, and you accelerate at a steady rate to 54 meters per second, that's my VF, and their time interval is 10 seconds. So what I have is a VI, a VF, a delta x, and a t. So I look for the equation that has that, and I end up with delta x equals 1/2 times t times VF plus VI. So 1/2 times 11.5 times 54 plus 13. And it doesn't matter if I put the 54 or the 13 in. It's all going to come up the same thing. And the answer is 3.57 meters per second squared. So number 16 asks, a ball is dropped from a ledge that is 40 meters off the ground. That means it's going to fall from there. So since it's dropped, your VI is 0. It's going to fall, so my delta x is negative 40. What's the final velocity of the object? And we know that the acceleration is negative 9.8 because it's falling. So this is what we just got through working in our free fall stuff. VF squared equals VI squared plus 2a delta x. So you put your 0 plus 2 times negative 9.8 times negative 40, because the object's going to fall 40 meters, losing 40 meters. And then when you get that answer, you're going to take the square root of that answer, and you're going to choose the negative answer of that, and you're going to say it's going to be going at 28 meters per second negative. On your test, you're going to have to know that it's a negative velocity. A ball is thrown up at an initial velocity of 32, and it's caught at a height that you need to determine. If it's caught at the highest point, then your VF equals 0, and your acceleration equals negative 9.8, and we're looking for the delta x. So this one is delta x equals VF squared minus VI squared over 2 times a. You have to put that in parentheses. So it is 0 minus 32 squared divided by 2 times negative 9.8. And that answer comes out to 52.24 meters. And that's a positive number because it's going up, and we don't have to find the square root because we're solving for delta x. All right, what's your final velocity? So that's VF. If you're at a red light, that means your VI is 0 because you're stopped. You accelerate for 7.5 seconds at an acceleration of 3.2 meters per second squared. All right. Do you have an equation that solves for VF when you know the VI, the T, and the A? The answer is yes. It's VF equals VI plus AT. So 0 plus 3.2 times 7.5. And that answer is 24 meters per second. And what is the acceleration of a plane that travels at 32 meters per second and speeds up to 59 over 11,000 meters? So we're using one we've already seen. A equals VF squared minus VI squared over 2 delta x. These are all on the front of your worksheet. So it's important that you label them correctly and then put them in correctly. 59 is our final speed, and each of those is squared, and we put that in parentheses, and then we're going to divide that by 2 times 11,000. And when you do this, you come up with 0.11 meters per second squared. So it's not a very fast acceleration. I should have had that as 1,100 meters instead of 11,000. All right, what distance is covered? Let's change to green, to something different. What distance is covered? That's going to be a delta x as one accelerates at 4 meters per second squared, going from an initial velocity of 20 to 45. So this one is delta x equals VF squared minus VI squared over 2 times A. So that's going to be 45 squared minus 20 squared over 2 times 4.5. Okay, and that answer is 181 meters. All right, we're getting close to the end. A stuntman falls off a cliff that is 60 meters high. Okay, so it falls off means his VI is 0. 60 meters high means our delta x is negative 60. His velocity as he hits the ground is VF, and we know that A is negative 9.8 because that's our acceleration due to gravity. So we put in VF squared equals VI squared plus 2A delta x. We put in our stuff in here. That's a negative 60. You're going to take the square root of your answer and choose the negative. So our answer is negative 34 meters per second. Number 22, a rifle shoots a bullet straight up at a velocity of 300 meters per second. What's the highest point the bullet will reach? So we're looking for delta x. We know that this is VI. At its highest point, your VF will equal 0, and your acceleration is negative 9.8. So delta x equals VF squared minus VI squared over 2 times acceleration. So 0 squared minus 300 squared divided by 2 times negative 9.8. And that answer is 4,592 meters. So if you shoot a bullet straight up from a rifle, it will almost go a mile up in the air. Or let's see, 1,500 meters is close to a mile. So that's about 3 miles up in the air. All right, on the back, we're showing you how some graphs look. A distance, if the object isn't moving, stationary means not moving. So if we do a distance versus time graph, the object stays in one place, straight left to right, horizontal. And that means that for the speed would be 0, so it's on the 0 line down here, and our acceleration is 0, so that's on the bottom line. If we're going at a constant speed, that means our change in speed is the same over all this stuff. We'll have a straight line, so we have a slope, and our slope tells us our speed. If it's distance over time. If it's velocity over time, then your slope will tell you your acceleration. So if I'm going at a constant speed, that means I'm not accelerating, then my acceleration will be a 0. I mean, my speed is constant. This is distance over time. My speed is a constant positive number, something above 0, and my acceleration is 0. All right, motion with constant acceleration. I'm changing speeds and I'm getting faster. If I'm getting faster, then I will curve up, meaning that as I cover more distance in less time, there is a bigger difference in these two lines over the same time interval. So if it curves up as you go left to right, then you're getting faster. Now, that's for distance, but if it's a smooth curve, that means I'm accelerating in a straight line. And again, this means a constant smooth acceleration, a constant acceleration. So my acceleration over here is a positive number that is greater than 0. So that's what positive means. And it is the same over and over. All right, so here's a distance over time graph. So we just talked about how to read one. Right here, we're curving up. So right here, we're going acceleration. From here to here, the line is fairly straight. So A equals 0. And we have a speed that is positive. And here, it's curving down left to right. That means your acceleration is constant, but it's going to be a negative, and your velocity is changing. Okay? And it's slowing down. So that's how you read some of the graphs. So good luck with your test, and I think this has been a comprehensive review, and to get you ready. Now, it doesn't do much good for you to just look at the review. You have to have tried to work them, and you have to try and do your best on these things as you work a worksheet. But it's a pretty simple process if you read it and just pull out what it is they give you. So good luck.